the break. And with that, I want to go straight to our next guest. Our next guest is somebody that I didn't need to spend a lot of time researching, given that I had a lot of background already. So Mark Porter is an amazing technologist, a good friend, and up until recently was my boss. So he's the person that can take credit for moving me from San Francisco to Singapore. So you can imagine that I'm thrilled to have him here with us at Techsylvania virtually. Mark is the CTO at MongoDB, where he's responsible for crafting the long-term technology roadmap and the vision for the company. Prior to MongoDB, Mark was the CTO of core technology and transport at Grab, Southeast Asia's super app that provides everyday services such as ride-hailing, food package and grocery delivery, mobile payments and financial services to over 100 million people, where he was from October 2018 to July 2020. And prior to that, he had an amazing career with senior leadership roles at AWS, News Corp, and Oracle. I can't do justice with this intro to him, but he's an amazing guy that I'm very proud to have worked for. So I'm sure you can learn a lot from him. In our 9 months that we worked together, I learned a lot from him. And his talk is going to focus on building modern applications and the data evolution. Please welcome Mark.
Hey, everybody. Good morning. I'm Mark Porter, CTO of MongoDB. First, Philip, it is great to see you. It's great to see you again after not being able to be in Singapore for so long.
I hope we can soon have a real whiskey again, but post-COVID.
That's great. So, hey, everyone, thanks for coming today. Today, I'm going to talk about data and how data is evolving. But first, I'd like to give thanks to the organizers who made this show happen and to all of you for attending. I'll start by saying I hope you're safe and well wherever you are. And though I would rather be in Cluj with Philip and you guys, I'm broadcasting today from my house in Seattle in the United States. So I invite you to think about the data that you manage and what the past, present, and future of that data is. Data throughout history has had different characteristics of speed and durability and distribution. We're going to have some fun talking about that journey. Today, we have data in many forms, accessed by many languages, and copied everywhere. We're going to have a quick pause in the present to see where we are. And then finally, we're going to follow those trends to see where they take us, and will inform how we think about data in the future. So first, let's talk about how we stored and retrieved data in the past. And when I say in the past, I really mean it. The first recorded human writing is from the Neolithic. This is an early cuneiform tablet from around 3100 BC, showing a tally of grain and livestock. From a data perspective, tablets were amazingly durable, something we all think is important. After all, how many other data storage formats do you know that last thousands of years? Unfortunately, the tablets fall short in the areas of queryability, backup ability, and to say the least, easy distribution. For the next 4,500 years, data storage didn't get much better. Then around 1440, along came the Gutenberg printing press, a game-changing invention that allowed hundreds or thousands of things to be distributed easily. Definitely a more scalable technology, and backups were pretty easy too, right? Ironically, durability went down as scrolls or books don't last as long as clay tablets. Notably, printed books were the first medium that democratized data significantly, shoving Europe headlong into the first information revolution, the Renaissance. Sadly, the next big step in data availability for the masses wasn't for 5.5 centuries, and we'll get to that later. Over the next 300 years, we started seeing huge collections of human knowledge. The first Encyclopedia Britannica was printed in 1768, for example. The 1918 edition, shown on the screen, promised to give you the sum of human knowledge in a mere 28,000 pages and 44 million words, around 256 megabytes. What about encyclopedias as a storage medium? Given their wafer-thin pages, their small fonts, and their concise writing, these books were likely the most dense storage medium that had been created so far in human history. Here is something that I and my peers all grew up with. Every house had one of these bookshelves. Compressing most of human knowledge, sorry, the clicker's double clicking for me. Compressing most of human knowledge, there we go, into about 100 kilograms. This is the 1999 edition. How did you find things in this? You started in one of the 2 index volumes, and you looked up the subject you wanted, often having to try many, many terms, and then you went to the desired book and page. In the longer articles, there were even tables of contents giving you 4 levels of lookup. Very painful. Ironically, though it was hard to find what you wanted, it was easy to find something interesting. When I was a kid, and this may just be me, I will confess, I'd often sit around by my encyclopedias and just open it to some random page and learn about whatever I found. This was the equivalent of the "I'm feeling lucky" button on Google we still have today. But remember, as strange as that sounds, there was no internet, libraries were inconvenient, and so when you wanted to learn something, you basically had only whatever printed material existed in your house. Sadly for us, but happy for trees, the last Encyclopedia Britannica was printed in 2002, and they moved to the internet. So it's time to leave the world of human-made data and start talking about how computers helped us with our data problems. Let's start with punch cards. They have a long history that you might not know about. First with programmable looms as far back as 1725, and then data storage in 1875, cards came into their own in the 1950s after over 200 years of constant use. This 12-row, 80-column Hollerith card that stored about a K of data could store both data and programs in multiple character sets, believe it or not. I'm actually relatively sure this is where the tabs versus spaces arguments first started. But all this data storage success caused a problem. Humans now couldn't see their data in a way that made sense to them. So now we have data everywhere. Personal computers and disks in the 1970s made it worse. Software tried to come to the rescue with programs like VisiCalc, think Excel, but easier to use, and databases like DBase in 1980. The problem is we had a full-on Tower of Babel situation. Because all data was stored in binary and all data was stored in different formats, it was impossible to exchange data between programs or even between the same program running on different types of computers. Something had to be done. So back in 1970, E.F. Codd from IBM came up with a solution. He called it a relational model of data for databanks. It's a great paper if you have an afternoon to spend. Since storage was expensive and nobody could predict how data would be used in the future, Codd's relational model normalized data into the smallest accessible units, rows, categorized it through a data dictionary, and told us to trust the computers to join it all back together when and how we needed it. Using the relational model, which you're familiar with, here we have the rows and columns you're used to. This represents some simple data about me and the relationships between that data. This could now be the same across computer types. However, just having data in a standard format wasn't enough. We needed a consistent language to query and update the data. And thus, in 1974, the SQL language was invented. It's an English-like language that you can use to how to insert, update, query, or delete data. The SQL language and relational concepts were a breakthrough, and the first commercial SQL relational database was released by Oracle in 1979. So now we had organized data and a way to talk to it. But for the next 20 years, we couldn't allow people and applications to share that well-organized data across the world. And so finally, after double-clicking on the clicker again, finally, after 550 years after the Gutenberg press, the web browser was invented in 1990. In 1994, the internet exploded, And for the first time, we had both easy distribution of data via web servers and easy consumption of data via web browsers. Magically, and this is the key insight, the two parties didn't have to know each other or communicate about either the location of the data or its format. There we go. I'm going to let you look at that for a second. During those 20 years before the birth of the internet, the data in those backend databases had been exploding too. And while humans were having trouble with the complexity, I mean, just look at the screen, it turns out that even the computers couldn't figure out how to do with it, at least not while processing updates and transactions. So operational databases weren't able to answer the questions that people wanted to ask of them. So we needed to find a different way of processing data to answer questions. Enter big data. For the first time, it was wildly acknowledged in 2005 that data in and of its own right had value. And that value was created by being able to query it, ask any question you wanted cheaply and quickly, a lot of it. Unfortunately, the relational model, which I started out with, specialized for high-speed, predictable, and perfectly correct transactions, doesn't naturally scale, and in fact remains very difficult to scale to this day in 2020. So in 2005, Hadoop was introduced, and you could ask almost any question you wanted, and we're able to start talking about terabytes and even petabytes of data. So now we had transactional databases on the one hand, and analytical databases on the other. And data was copied between them and used differently. All good, though COD wouldn't have been happy about the duplication. But inside those transactional databases, something was going on, something bad. The databases couldn't be trusted to return data in predictable amounts of time. As I said, the joining of data between the tables was so complicated that computers could no longer do it predictably, even with the smartest engineers in the world helping. We needed to find a new way to simplify our data. Thank heavens, along came JSON. As you can see, JSON allows the storage of complex data structures in formats which are friendly to both computers and people. And rather than having to teach your programming language to speak English in SQL, you could just use your native data structures. And yes, you even got transactions. So people decided that data wasn't the same and thus didn't need to be stored in a single kind of database. Between document databases and relational databases and others, we're able to process our data correctly, despite all the controversy that's going on about that even today. In our final slide on the past, I'll highlight the component that hasn't scaled well over the last couple thousand years. Yes, the human brain. We're no longer able to handle the complexity of our software and the data in our systems, and we can't reliably reason about them. Thus, a major effort over the last couple decades has been to decouple systems into smaller and smaller pieces. By going to this microservices architecture, we've sped up writing the programs that let us access our data and made it more predictable. Whew. So this gets us to the present day. What is the situation now? Where are we? So first, microservices are the norm. In addition to removing complexity and coupling, microservices allow your teams to scale across the safety of defined APIs. Scaling, in fact, is the key today. More than ever is coming in, and we scaled up in size by going from megabytes to petabytes. Any data store used today needs to be able to scale up and out. Today, we also require our data stores to have a flexible data model, as you know. But even with all this progress, things aren't working as well as they need to. We're still not where we need to be. You've always been able to spread your data between online hot stores and near online cool stores in order to optimize storage, speed, and cost. And you tier your data to do this. The problem is that you use different tools in most applications today to query the data, and you can't join the data, which means we can't make the right decisions. And so in the last couple of years, we've created a middle ground. And that middle ground we call online archives. An online archive is a service that lets you have your object data store be joined together with your live database cluster as if it's still in the live database cluster. With an online archive, you can now have queries that get data from both the real-time cluster and the cloud object storage at the same time. These are called federated queries. Various vendors have products like this. In our example, it's Atlas Online Archive. So enough theory about data. Let's actually look at an example of data and how it benefited an organization. MongoDB partnered with WildAid to build an end-to-end application using our data platform. And I'm going to tell you, we both learned a lot along the way. This is an actual WildAid logbook from inspections in Myanmar. No matter how accurate the book is, inspectors on boats don't have access to the data from the prior inspection. And even if you put it in a traditional server and web client, what good would that do you out on a boat without network access? Fisheries officers jump from one boat to another, often far offshore, to do inspections. They might encounter safety violations or even illegal behavior. It's really important to know about prior visits to that boat. So we used our sync technology to give officers phones up to the date data as of when they left cell coverage, and then any changes or additions are made that are out of cell coverage are immediately synced as soon as the phone is reestablished a connection. And so to make that work, we built two apps, an iOS and Android app, a serverless web client using MongoDB charts and MongoDB Realm, and we connected it with the database that keeps everything in sync, including inspection photos in S3. Just like most applications, the data was tiered and federated using Atlas Online Archive and data stores from other agencies to federate together. And so here's the finished result. Before this application, the most important metric that WildAid was able to track was the violation rate. That's it. But now they can do so much more. They can check for violation hotspots or areas they're not patrolling visually, all from in the app, and all synced as soon as the network allows it to be possible. And back at headquarters, they can do analytics on the tiered data with those federated queries I told you about. So now we're at the part of the talk where we're going to talk about the future. The evolution of data has been constant. It's been very exciting. In fact, if you track the trends of innovation in the past to the future, it's speeding up. So let's look at those trends. First, some high-level observations. Data is going to continue to grow. There's no doubt about it. The sources and formats of that data are going to multiply. You all deal with this every day in your applications. All the data comes in and it's dirty and it's not what you expected and it needs cleaning. And unfortunately, our users are getting more and more demanding and expecting real-time access. Even though the data is now spread all over the place and we have to join it together. So as technologists, what the heck are we gonna do? So the last part of the presentation is spent me giving you some advice over what I've found as what we need to do to prepare ourselves for the future. And so let's just get going with that. So first off, we need to assume that data will keep growing. It's been growing for 5,000 years. So build your app on a set of tools that scale naturally. Assume scale from the start. Don't just have success of your application when you get featured on the App Store, turn your app into a failure when it falls over. Use technologies that automatically tier. Don't leave this for later. Note that your metadata from provenance will be just as big as the actual core data of your application. And finally, pick software systems that scale with you. Avoid abrupt discontinuities in cost or performance as you scale. Next, data sources and formats are going to keep multiplying. When we were using relational databases, we had the luxury of forcing data into a rigid structure. We just told people what to do. That's not okay. While it might be okay with a single database, it won't serve the large sets of diverse data that you want to ask questions about today. So your applications and tool chains are going to need to be developed to accommodate data flexibly where needed and enforce those rules. Now, in relational stores, you did this with constraints, but even in non-relational stores, you can have your document and your document cake and eat it too with JSON schema enforcement. Next, build modularity into your data so that new formats can be added at will. Use APIs for your tried and true data formats. Make sure that you use fuzzing. Make sure that you feed in not accurate data and make sure that your applications actually live with it. And in summary on this point, aspire to make your data engineer's life more fulfilling and less filled with drudgery. Data is never going to be clean, ever. And while dirty data in the past may have been really dirty, think of those clay tablets, now we mean data with unexpected things that are either present, absent, incorrect, or out of an expected range. You might be scared of those things, but instead cherish them, as there might be new things you didn't know about. Now, I'm going to be really direct here with my experience with Philip at Grab. Manual data cleaning needs to go away. Use AI. Invest in your systems to build a core set of model and test it and use it against all of your new data. Some of the data exceptions that come in may be new. They may not be bad data. They may just be the world changing under your feet. My personal experience with AI at the great Grab team is that if you invest up front with an awesome team of data engineers and you give them the resources and budget they need, you can automate almost all data cleaning. Your users are going to demand more and more real-time or near real-time analysis, and you need to provide that. So don't use batch processing like Hadoop. And the best way to make big data scale is to not copy your data, or if in the most, copy it once. So while transforming data is inefficient, accept the debt when you need to do it, and where possible, get the data into a format that'll be efficient for all the different queries. And in particular, avoid time-consuming and non-scalable joins. Finally, data is going to be everywhere, and you know that. It's scattered through your applications, your servers, out through S3 and Glacier and every place else. And so sadly, all applications start with data in one place and then get torn down and the data is distributed. Make sure that you hide your data behind APIs and never allow direct access. That way you can refactor the storage without having a crippling stall on your productivity. Spend time to invest in your data engineers, your data scientists, and your machine learning engineers. Budget, build tools. And if you settle for legacy tools, you're going to not be able to make decisions because you're bringing data together from multiple places. So today, we started talking about some of the lowest bandwidth data you can imagine from 5,000 years ago, and we ended up talking about massive amounts of data that move around like magic. It's been quite a journey, and thank you for going on it with me. I've enjoyed it a lot. I hope this talk has helped you think about your data. While I always try to create value in my talks, this one has actually been a bit of a departure for me, as it wasn't about a product or a feature or technology, but instead was meant to be provocative and get you thinking about how you're going to treat the data that your applications are entrusted with. Note that I'm available to talk to any of you on LinkedIn at Twitter at Mark Loves Tech, which I truly do. And finally, stay safe in this complicated world and take care of yourself and those around you. Thanks for listening, and I'll see you in the Q&A, and I hope to see you next year in Cluj.
That was amazing, Mark. Thank you so much. I think, oh yeah, there you still are. So this was a wonderful tour de force through 5,000 years of history of the database development. So I'm curious, like what you'll come up in the next 10 years. Hopefully it won't take quite 5,000 years to get us to the next stage of evolution. So thank you so much for that. As Mark said, he's going to be available in the Q&A stage, so you can ask him all the difficult questions after that. It was quite remarkable to see him do a presentation. He's much more a documents guy with like long reads and like documents. So that was a quite new thing for me. So thank you again, Mark, for joining us, and thanks for agreeing to do a Q&A after this.
Thank you so much. Everyone take care of yourselves. I'll see you in the Q&A.